Bonnie at the Grass Valley Library. Thanks for joining us today for Random Acts of Science. Today we're going to be studying saltwater and what it is that makes it so buoyant and why it's easier to float in the ocean than it is in a pool. So we're going to talk about that a little bit. If you haven't already picked up a bag from the Grass Valley Library or the nearest branch to you, you can go ahead and do that. You'll find pretty much everything you need for the experiment inside the bag. On the outside of the bag is a QR code. You can scan that with your device and it'll take you right to this video on YouTube. So what's in the bag today? First of all, the experiment sheet. This has all the information you need to do the experiment. It tells you what's in the bag and the different steps that you take to complete the experiment. On the back side is an explanation of the science and other links to resources if you want to study up a little bit more on saltwater. Also in the bag, there are 4 sheets of paper. We're going to need those here in a minute. We have 3 packets of materials. The first one is baking soda. We have another packet of sugar and another packet of salt, and they're all marked on the outside, so make sure you're keeping straight which one is which. And then the last thing in your bag is this plastic jewel. Yours might be a different color. We're going to use that to test the buoyancy of the water. So that's what's in your bag. Let's go ahead and get set up for the experiment. The things that you're going to need from home, in addition to what's in the bag, are 4 clear glasses and some water. So we're going to use what we've got here. On each one of the pieces of paper, you're going to want to mark them with the 4 different controls or the 4 different variables that are going to be in our experiment. First of all, we're going to have a controlled variable, and that is going to be the water. So you're going to mark control on one sheet and put 1 glass on top of that. The controlled variable is the thing that does not change during the experiment. The variables are all the things that do change. So we're going to have a glass of water that's not going to have anything in it so we can see what happens when we use regular water. The second thing we're going to have is salt water. So you're going to mark salt water on this page. The third one is going to be sugar water. And the fourth one is going to be baking soda water. And we're going to have a cup on each one. And the next thing we're going to do is add water to each of the cups, which I'll do here. As long as you have just about the same amount, it's going to be fine. All right, so we're going to go ahead and put 2 tablespoons of salt in the saltwater glass. Doesn't have to be exact, but it's kind of nice to be close. The next one's the sugar. So I've got the packet of sugar. We're going to put 2 tablespoons of sugar into this glass. The last one is the baking soda. This is a little more powdery. Okay, once you've got your glasses full, you want to stir it up a little bit to dissolve the substances. You might have a little bit of powder or grains of salt on the bottom of your glass, and that means you've got enough in there. So, okay, we're ready to keep going with the experiment. The last thing we're going to do is take this jewel and we're going to drop it into each one of these glasses. So it's in the process of scientific experimentation, it's always good to have a theory that you're going to try to prove or disprove. So think about it for a little bit and tell me what you think. Is this jewel going to sink or float in the water? And then I guess we'll go on from there and see what happens. So here we go. I'm going to pop it in the water. It went all the way to the bottom, so it did not float in the water. So that's our controlled variable in the experiment. Any thoughts about the salt water? What do we know about seawater and salt water? It increases the density, right? The salt increases the density of the water, making the jewel just a little bit more buoyant. Let's see if we have enough salt in there to make this float. I hope you can see that. It went down and then it came right back up again. So the salt is dense enough to help the jewel float on the top. How about sugar? Sugar's quite a bit like salt. We dissolved it in there. Let's see what happens with the sugar. Nope, it just went right to the bottom in the sugar. Sugar is not combining with the water in the same way, so it's not making it any denser apparently. And then how about the baking soda? So hopefully you can see it starting to float back up towards the top here. One thing that's happening here is the baking soda has a chemical reaction with the water and it forms carbon dioxide bubbles. And if you look really closely at whatever object it is that you drop in there, you can see those bubbles forming on the object. And what happens are those bubbles end up being like little life jackets, and they add buoyancy to the object. And over time, and especially if we added a little bit more baking soda, that jewel or whatever you drop in there is likely going to keep rising till it gets to the top or gets suspended somewhere in the middle. So I think that's about the end of our experiment. We tried all 4 substances. I think you probably realize by now that salt in water is what makes the sea as dense and buoyant as it is and allows things like everyday objects, including your body, to float in it easier than in a regular pool, for example. You've also probably realized that salt and baking soda have the same type of properties. They create the same type of buoyancy in water or density in water, and that sugar just doesn't. It has a different effect altogether. So feel free to experiment with this. Throw in some different objects. See if you can get things to float. Grapes, eggs, whatever you got around the house. Those are all kind of fun things to throw in these things as well. And I hope you had a good time and learned something. Next week we'll be back with a new experiment. So until then, keep practicing random acts of science.